Good morning, participants. Hope I am audible. You may write on the chat box your response. Thank you.
Yes.
Thank you. Thank you. Thank you. Thanks all. Thanks all. Okay. So I again welcome you all the participants in this session one, day two of this 1 week long FDP. Yesterday was the first day. There were 3 lectures happen. The first lecture was basic introductory lecture session where we have covered about the basic terminology of machine learning, AI, training, testing, and many more things we have seen. We have also conducted a hands-on session on the R where the functions were demonstrated that were mostly used for data importing and the similar things. The second session was on the neural network, deep learning, various architecture we have seen. We have talked about the weight, activation function, threshold, layers, all those things we have completed yesterday. Yesterday, last lecture was on the yoga and meditation. So today, the first lecture is going to be on the decision tree. As you can refer to the schedule we have already with us. I'm going to take that session about the decision tree. There is no doubt all of you must have aware about a bit about at least the decision tree is something is algorithm comes under the machine learning. So that is the minimum information, the knowledge. Nowadays, I may expect to everybody having some idea about the decision tree. It is and something algorithms going to use for some purpose in the machine learning, and the name is given the decision tree. There are various kind of decision tree algorithms, and the list is very long. So one of the fundamental decision tree algorithm that is called ID3 I will cover. Before dive into the detailed discussion about the ID3, it always better to understand the history and background of the something we start learning new. Because decision tree, I agree, comes under the machine learning, but it is their own space. It is their own separate dimension. So we need to understand how the name was given the tree, how it is different from other machine learning algorithms like linear regression, KNN, logistic regression, and many more are there. So let's understand about the background. Start with the example. Suppose you are as a sales manager or COE in a big company, and the company business is to sales the policies, or they encourage people to go for investment. You have a lot of investment options. You sell the investment options like mutual fund, share market, or many others. The all this area that your company deal with, and you are new in some city, or you can say in some country. You want to attract people so that they can invest in the different portfolio through your company, so that anyhow you can give hike in your business. You may help your company to establish in that city or country. And you are new. So take a simple example. You want to approach to the customer and assume that you have a data set of people who or citizens where you have opened the office. So one approach to tell about your company, your benefit, if you somebody will go for the investment through your company, you need to talk about your benefit to the people. So the one of the solution may be that you hire some uh, persons who may will start calling to the people one by one. You have a set of such employee or telecaller, you can say, that start calling to each and every person that the detail is available with you. So what happened? This is called brute force approach in any way. So what happened in that approach? Since it is too much time taking approach, because you have to reach out each and every person, you have to hire a lot of telecallers. It is time consuming, plus also demand the investment uh, for hiring all those things, many licenses you have to take. And so you don't need to such much money, because and that way what happened, the success ratio, success chance is very less. So what data talk about, the survey talk about, suppose you have called 100 persons you have called. The data talk about there is a less than 1% chance, less than 1% chance. Your probability is less than 1%. What is the meaning of that? If you call 100% to sell out your policies, your investment plan, it's very hard to convert the one people out of 100 call. The survey talk about it is one out of 1000. If you are achieving this much of success ratio, it is also very good. So you try to understand 100 times you have tried, 100 people you have reached out, hardly one people is ready to see your policy, ready to come your office and have shown their interest only. The person didn't invest till date, they have shown their interest uh, on your company, on your policy. So this data is enough to talk about this technique, and this methodology is not good. So what is the other methodology? So machine learning, AI come in this area, and the people started using the concept of learning or predictive capability of the machine learning algorithms, so that they can help out to filter out the persons, and they can predict you should call that person or not, you should reach out that person or not. So what I am saying, suppose you have a list of people like P1, P2, which person higher chance to show interest in your policy, or they will purchase your policy or investment plan. So it may predict P1, the person will not purchase your policy. P2 will not purchase your investment plan. P3, they will purchase. P4, they will purchase, like that, like that, like that, like that. So how it become very fruitful for us, you should not call those persons for which your model has given the negative output. The less chance for Since we are in area of machine learning AI, we're talking about, we must have the data set. So I will directly start from the data set. As we have discussed, we have already the data. We have a previous data. We have a historical data. If you don't have historical data, if you don't have the previous data, you can't apply any machine learning model. You cannot train it. So for this purpose, the data set is given to you. There are many features, but for a simplicity, some couple of features in the data set I have selected for the demonstration. Like the name of, these are the already customers. Okay. The name of person, their age is given, gender is given, whether the person is employed or not, salary, marital status, many parameters are there. And the last one is try to understand, it is a target variable. It is output variable. It is given this person have already invested earlier through your company or not. Yes means all those persons who are really real customer of your company. They have gone through a lot of policies and investment plan through your company. No means they have not shown the interest. That are the data set you must have. There is no compromise with that one. If you don't have data set, you can't apply any machine learning algorithm. So try to understand the data set. We have a data set. These all are the input feature. Okay. Because whether the person is married or not really going to impact, the person will go for the investment plan. Salary is also a big issue. I'm interested to have to purchase a plot, share market, mutual fund, but my money doesn't or my income doesn't support it. Similarly, the person is employed or not is also a big issue. Age is also does matter. Many person at the early age earn a lot, but they are not much serious for the investment. So age is also matter. Gender is also matter. Name doesn't matter. Serial number and name are not important parameter that I can understand. Other input features are important. And this is output feature or target variable. Agree? So I will take that example to demonstrate the working of decision tree or idea behind the decision tree, how it has started. So I hope this uh, diagram is visible to you. So what happened? I will start with some assumptions, like the group of data is given to you. These are the observations, these are the data. Left hand side, the group of person images are there, means this is a data set you have that are mixed data set. Okay, thousands of data sets are there. Initially, you have segmented your data into the three group. How you have decided to have categorized into the three group, two group, or five group? Don't worry about that. You understand the concept only. Initially, whole data set were divided into the three group based on the age, like the age between 20 to 25, age between 25 to 50, and third segment is 50 to 70. Good morning all, please. And the third segment is the people that comes between age 50 to 70. So three segments are there. You might have observed it is written like 15%, 80%, and 5%. So what is the meaning of that? When you have segmented your data based on the age into the three category as given, and you have further analyzed and you have concluded those persons in that group, the first group that are between 20 to 25, only 15% person on that group have invested somewhere, or you can say they are already the customers, or they already purchase some policies. Similarly, when you have gone to the further investigation to the second group, age between 25 to 50, then you have realized, it's very good. 80% of those samples, those populations who comes between the age 25 to 50, 80% of people normally go for the investment. They are more mature. They think about the investment. And the later one, the last, the age group between 50 to 70, only 5%. people go for the investment. So here, if I ask the simple questions, which group you will select for calling, for contacting them? Suppose your company want to sell out some policies, investment plan, which group you will select? There is a two group, 20 to 25, 25 to 80, and 50 to 70. The second group, Sasiji have written correctly. Because 80% of those, or 80% are chance if you go for with this group. That's why that is only the reason to select the second group. The first and third group we will discard it. So what you have done, a big bunch of people you have already removed from your data set, and you have find out, and you are only interested all those set of people that have more chance for go for investment. So you have reduced the search space. Ultimate what you are doing, your objective is to find the given big data set, only those set of people that whom you can contact to sell out your policies investment plan, and that must be more fruitful. Okay, so everybody understood the second group is the important under this scenario. Okay, done. Then further what you have done, then you have realized still I'm not able to, I don't have money energy to call all the persons that comes in that group number second. Then you have to again drill down, you have to again reduce the surface space. Then what you have done, you have divided that group based on the gender, like male and female. So upper side all the females and lower side all the males. Same question again, which group you will select for the further processing, or to whom you can focus on? The males. I think it is damn clear because the higher chance to get the success if you contact them. There's 70% chance out there. I think everybody agree. Then in the next level, you have to select this group because the 70% are chance to get the success. I think everybody agree. Thank you. Again, because you have a lot of features and those features are important, you again pick up one feature. Thank you. Again, you have picked up one feature that is called marital status. Okay, see the status. Now you have selected the age 25 to 50, only males. Under that, you again drill down marital status, married or unmarried. So then you have again concluded if the male are married, then 70% chance for go for uh, investment. Again, similarly, if you have more features, you can drill down married if they have children or not. If they have children, they are more serious about their future, more serious about their family economical status. They want to strong it out. So all those married males who have the children are 80% of them have invested, interested for the investment. So you will go over there. So you do one thing. You just again realize you can consider the left hand side as a root, and these are the branches. These are the branches. So it is a kind of tree structure. It is a kind of hierarchical structure. So this kind of phenomena and method, when based on the different feature, different variables, we start segmenting your data set layer by layer, layer by layer, layer by layer. And the leaf node are those that you call the class label, that you call the results. So suppose you have ended over here. You suppose that at the last you have ended over there. So this is the prediction. This set of people, you see what happened here, 1,000 people were there, suppose. Then you have started drill down. And this is the children, male person. You will mark there, they will purchase your policy. always be a prediction so that you can take the appropriate action. So it is a kind of tree structure. How you are creating the tree, you are realizing, you are investigating the features like age group is a feature, marital status, gender, all are the features. So how the feature is important, how the discriminatory power a feature may contain, based on that you can define the labels. Okay, and you can go for further split the branch again and again until you will find any good solution. So it is a kind of tree structure. So any algorithm that based on this kind of phenomena, this kind of concept, we call it uh, uh, a decision tree, or tree structure, or developing the uh, hierarchy of given data based on the discriminatory power of the variables. So this is the concept behind the decision tree. So I hope it is clear to everybody. Yes, thank you. Now the important question is that, yeah, everybody might have thought about, yes, thank you, thank you. Yeah, okay. Now the question is important question. Technically, because mathematically we have to define. Why the age, the variable I have selected the first? Why not marital status? Why there is a age? Why not marital status or gender as the first label? I maybe choose maybe selected. Why the age group? After the age, why not marital status? Why gender? Why not gender at the last? Because these are the features. I want to say, go to the table. Gender is a feature, age is a feature, employment is a feature, salary is a feature, marital status is a feature. Which my question is that which feature you will select first for split the root node, or as a root node you can say. How do you decide it? That is a big question. Everybody to understand it. Then you will enjoy the all the lecture. Otherwise, it will be like a robot kind of teaching. So the question is that when you go for the tree induction, you have to choose the variable for the splitting. Then next level again, the next variable you have to choose again and again, again and again. So how do you decide which variable you should choose first? Then next, select for the next split. Okay, so it will not be known. Uh, or marital status depend on the age, depend on the variable. No, that is not correct answer. So Priyaji, it is not correct answer. Again, suppose I have encoded all those variable name x1, x2, x3, x4, x5. Then how do you decide it? Because you have a domain knowledge, that's why anyhow you are trying to relate the age is related to marital status, like that, like that, like that. Okay, but it is not true. It is not happen like that. Suppose I have encoded all the variables name. I'm not writing gender, age, and employment. I'm writing here v1, v2, v3, v4. Then what happens? How do you know this is the v1 is for a marital status and v3 for the gender status? Then how will you decide it? So, you got it my point? There should be a scientific reason actually, or some mathematical reason, I must say. Because when algorithm will take the data, the algorithm don't know what is the meaning of marriage. The algorithm don't know what is the meaning of employment, what is the meaning of age. Your algorithms work on mathematical formula. I think everybody agree. So this kind of understanding, because age is depend on that this doesn't work in the machine learning. In a human level decision making it works, but machine learning you need to feed something concrete. Okay, that, that we are going to discuss. That is the main crux of decision tree, that you need to understand how the decision tree select variables as a split node, and then that you need to understand. So that we are going to discuss. Okay, so let's have a look about the decision tree. A decision tree is the most powerful tool and algorithms that can used for both classification and regression. You try to understand. Algorithm decision tree have the capability. There are many kind of decision tree. Okay, some of the decision tree are being used only for the classification. They can't use for the regression. Some decision tree only for use you can only use for the regression, cannot be used for the classification. Some decision tree have the capability, can be used for both kind of problems, classification and the regression. So decision tree is a big chapter, that is a big branch. Decision tree, a single name, you talk about decision tree, there is no algorithm like that. So many person confuse that, like a KNN, like a SVM, like a linear regression. Decision tree is algorithm. No, decision tree is the concept. Decision tree is the domain. Under that, many decision trees. That you have to understand it. So decision tree is the area. Okay. Decision tree is a flow-like chart. We know, we have seen their structure, their hierarchy is similar to the tree. That's why given the name decision tree. Now you need to understand the terminology. That's very, very, very important. Each internal nodes denote a test. What is the meaning of internal node? That node, that we call it, terminological point of view, we call it split node. We call it decision node. We call it internal node. So many books are using the different words for the internal node. Like some books are calling it internal nodes. Some call it decision node. Some call it split node. Please check your mic status and please mute it. So once the node testing is over, we need to split the branch. So what branch represent? Branch represent outcome of the test. Whether the person is going to be yes or no, yes, no, yes, no, yes, no, like that. And each leaf node, that is called terminal node, holds a class label. Means suppose you have a binary classification. So you always want answer yes or no, happy, not happy, like that. A ternary classification may have a 3 options. And similarly, you have a multi-class classification. So in the decision tree, so whatever the decision tree, finally you will have like that. Suppose this is the decision tree you have gone through, and this is the complete decision tree. Okay, so these are the leaf, or you can say external node. It always with the class label, always with the class label. Means either here you have to predict all yes, no, yes, no. If yes or no are the class label. If you have a class label happy, not happy, so it any of the leaf must be either happy or not happy. So that's all those things. So it is the terminological understanding we have made about. I think this is clear to everybody. What are the internal node? Internal nodes are the variables or features you have to consider. Then you have to apply some test. If test is how it is, we have to talk about. We have to go for further splitting. And finally, once the tree has grown completely, all the leaf node must be a class level so that you can predict something. Okay. So will there be one yes at the Sasi ji asking, will there be one yes at leaf? One yes means what? So all the observations in that leaf, if leaf is yes, all will be yes. All will be go for the investment like that. If 80% are there, means we will talk about that group of person will invest. You will say yes, 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 yes. Other you will have to discard. Leaf you have to talk about yes means all the observations in that group your model is saying they will invest yes. In particular leaf node, there is no partial decision that some of them yes and some of them no, it is not possible. They will have a common behavior. Okay, bunch of yes. Yes, all the observations in the leaf will be predicted as a yes. It is clear? Yeah, thank you. So growing a tree involves deciding which parameter or choose. That's I'm talking about splitting feature. Which feature you will use it? Whether age, whether marital status, whether gender, which feature you will use. So we have to select the node for the first split. So question was what condition to use? What is the scientific condition? What is the mathematical formula that you are going to use to choose the feature for the first split? And this thing is also so important. If you have a limited number of features, then you have a tree with 3 or 4 or 5 labels, but you have 1,000 features. So you think about how big that tree will be. So it is an iterative process. Pre-induction is an iterative process. Somehow you have to stop it. Otherwise, too big decision tree create a lot of problems. If the time permit, I will discuss. It is not in the scope of discussion, but if time permit, I will discuss. Otherwise, I will discuss what kind of problem it may create. Tomorrow lecture. Tomorrow again the decision tree will be there. Well, different algorithm I will cover. So I will try to cover it. If the tree is too much big, too much large, it itself a big problem. So we have to stop the growing of the tree in somewhere in between. So that is called a stopping criteria. Or any of the iterative algorithm you try to recall, like if you are creating the Fibonacci series or factorial through the recursion, you try to recall your days. So you need to apply when recursion, you always define the stopping criteria. So similarly, the tree induction is also a recursive process. So the stopping criteria, you have to define it. I will discuss some of the stopping criteria that's under the scope of that discussion. What is the recursive splitting? Because decision tree induction is a recursive process. Now I'm going towards to the main algorithm that I'm going to cover. The algorithm name under the decision tree that is called ID3. One of the famous algorithm under the decision tree that is called ID3. That is the target to cover today. So I'm going into the that direction. So what the concept of recursive splitting, try to understand. In this procedure, entropy, it will come. Reduce, yes, come the entropy, Gini index, everything will come. Yeah, we need to calculate the entropy. So in this procedure, all the features are considered. So you can't discard based on your choice, based on your understanding. You have to consider all the features. All the features are candidate to become the node, to become the root node, or to become the splitting node, better to say. In every step, whatever the as initial, all the features are considered or they are candidate to become the splitting node or become the root. Okay, we have considered, then what? Different split points are tried. Split point means either selecting with age, then select with gender, then select with marital status. All the splitting possibility we have to try. So try to understand the complexity of the decision tree, complexity of the machine learning, how they work. They work very different way where the random selection is not possible. So all the splitting possibilities or splitting points they tried and tested using some cost function. And the cost function may be accuracy, maybe something. Cost function may be loss, maybe accuracy, maybe something, maybe some of a square error, any kind of the function you can create. Okay, and that cost function calculate the how much cost that split carry. Okay, a lot of splitting criteria you have, a lot of possible split node you have applied each and every splitting node that is possible and calculate the cost function. Now the cost function will help us which node you should select. So the third point is that the split with the best cost means in term of accuracy, if it's the highest, in the term of error cost function you have taken, it must be lowest, is selected. The split that costs least in chosen means all the possibility you have tried, which particular setting give you the highest accuracy, or whatever the cost function you have defined based on that, the best cost function they have given, which node you need to select it. So it is not like the age randomly I have taken, the gender randomly I have taken, marital status randomly I have taken. No, there is a mathematical process behind that. You have to choose each and every, you have to evaluate by using the cost function. Based on the evaluation results, you have to choose the best one. So that is the one process is over. You have selected the root node only. Then you have done for your split. Then again, which node you have selected then? Suppose age is selected first, it is over. You have split your tree, you have multiple branches. Then the next level, which node you will select? Which variable you will select? Again, the choices are there. The same process you have to repeat. The same process you have to repeat. That is called recursive in nature. Okay. So conceptually, it is all about the fundamental methodology and idea where most of the, I must say almost all the decision tree algorithm work on this idea. Now, different algorithms are different based on the type of cost function how they are using. Either like Rijuji have written, some may use the entropy, some use the information gain, some use the Gini index, like many options are there. So based on the different internal cost function, internal splitting criteria, the algorithm have a different nature. Okay, so that is type. I have just tried to write some step in the sequence so that it help us to better to understanding the overall working of the any decision tree. So the entire data set first you have to consider means all the features. Select the splitting criteria, whatever the splitting criteria you want, whether Gini index, whether the information gain or any other, you can define it. Then split based on the function you have taken. You have to apply to all the variables, which variable favor you take it and multiply, split your decision tree. Repeat that process multiple times until the stopping criteria match. So once the growing stage is over, that is called growing stage is over, you will stop it. There is a final decision tree. Once you have a final decision tree, you can use for your prediction purpose. So that are the fundamental basic steps that almost every decision tree follow it. I think it is very simple and damn clear. Now going to start exact algorithm that I have target to cover today. That is the ID3, and the complete name or full form of the ID3 is the iterative dichotomizer. So it is not a new one. It was invented or discovered or published in 1986. And there are various advanced version of the ID3 today we are using, like C4.5. That I'm not going to discuss over here. The name are so famous. If you are in this area, you must listen something. C4.5, C5.5, like that. These are the advanced version of the ID3 are heavily used nowadays. Okay. So suppose if I going to read it out, the working of the decision tree or ID3, it bit difficult to understand. Like what it is written, the ID3 begin with the original data set S capital S given to you as a root node because whole data set is there. On each iteration of the algorithm, it iterates through every unused attribute of the set S, every unused attribute. Try to understand. Once the attribute you have selected, it cannot be a member of the second level of the split. Suppose age is selected, the age must be outside. Remaining, when you grow the tree downside, the age cannot be a candidate of the next time split. That is called unused attribute. Calculate the entropy because ID3, the original ID3 was based on, original means the first ID3, the basic ID3 algorithm was based on the entropy. To calculate the entropy or information gain or death attributes. Okay. It then select the attribute which has the smallest entropy or the largest information gain. So if you have the smallest entropy, automatically it will have the largest information gain. I will cover entropy information gain coming uh, uh, time in this lecture. The set S is then split or partitioned by the selected attribute to produce the subset of the data. So that is the whole working of the ID3 presented over there. It's a bit difficult to understand. So I will explain the ID3 with the numerical example and each and every internal working operation will cover in very detailed way. And I am sure everyone who is really attending that FDP seriously will understood decision tree without any effort. So suppose this is the data set is given to us. Name, gender, salary, marital status is given as input parameter. And we have investor yes, no is a target variable. The data set is given to us. Moving ahead, typically first we have to calculate the entropy of the class. The working I am going to discuss. Step one, we have to calculate the what is the entropy. I will cover. First, try to understand the step. First, entropy of the class we have to consider. We have to measure. We have to calculate. Then we have to calculate the entropy of the attribute. So two kind of entropy we have to calculate. Class entropy means this target variable entropy. Then we have to calculate the entropy of each and every variable. Okay. Further, once we have entropy of the class, entropy of the features, we have to calculate the gain of attribute, information gain of the attribute. And select the attribute for the splitting node as a splitting node, which gives the highest information gain. It means that the feature is best for the split. Automatically, I'm going to discuss about how to calculate the entropy of the class, entropy of the attribute, information gain of the attribute I'm going to discuss. First, let's have a discussion about the entropy. Yes, Ashish, I will going to cover the bit on the class. Please. So you are confused with the class and attribute. Ashish, what is the question? I didn't get it. In the class, in the data set, you can find it. It is a target variable. We call it as a class variable. And other variables are the attributes. So terminological difference is that these are the internal variables or attributes, and our target variable we normally call it a class variable. Let's have a discussion about the entropy. So the simple question, entropy is something we have to measure it. What is the range of entropy? Let it be an interactive session. So what is the range of entropy? I'm not going to ask the formula of entropy. Entropy between 0 to 100, -1 to 1, 0 to 1. What is the range of entropy? If anybody have idea. Yeah, thank you. 0 to 1, 0 to 1, 0 to 1. Okay, very good. What is the best case? What you want? Entropy with Zero entropy with one. Okay, Abhishek ji, yeah, correct, correct. Everybody is writing. Oh, entropy one is good. Okay. Someone is writing entropy zero is ideal case. Very good, very good. Entropy one means what? That kind of entropy value should not be there. Like, what is the worst? Okay, and I'm asking the number between 0 to 1. 1 is the worst. Okay, 1 is the worst. I don't think 1 is the worst case, Dr. Chinmay. Worst case is 0.5. Now you think about why. Worst case is 0.5. Any attribute having entropy 0.5, worst case, you should not select that attribute at all without thinking a bit. That is the most worst attribute that give the entropy 0.5. Okay. Okay. So let me understand with the example. The entropy is very interesting, very interesting. So please give your attention for the next 5 minutes. Suppose we have taken an attribute age and we have taken attribute marriage. Two attributes we have taken. Don't put your mind, just what I'm saying, you try to understand. And I want to see based on those attributes, the person will invest yes or no. Okay. You have gone through, suppose there were 100 observations were there in the given data set. 100 observations were there. You have selected under the consideration the age, and you have found the age group have only two sub-level. Suppose it is not a number, young and old. Okay, that's the categorical variable. Suppose age is young and old only. We don't have numbers like 23, 25, 25. Age front of the person, it is given young, 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 or old, old, old. I think it is clear. Okay. Then you have decided, and under you, when you go for the analysis, you have find out who was the young, who was the young out of 50% have invested, and out of remaining 50% don't have invested. Similarly, the old one, the 50%, whatever their percent I'm talking about, are invested, or 50% are not invested. You take the sum assumption. Similarly, marriage. Again, there are two sub-level. The person is married, yes or no. Okay. Who are the young and who are not young? Who are the married person? 80% are invested and 20% are not invested. Similarly, 20% or 25% invested, 75% not invested. Okay. Now, my question is that this data I have given to you only. I have two attributes only. The picture is clear. Which attribute is useful to select, to decide, and give the more better picture for a particular person will going to purchase the policy, yes or no? Which attribute having the more discriminative power? Which attribute is useful for you? You tell me. Yeah, marriage, I think. Why? Yeah, Dr. Chinmay, yes, very good, very good. Because when The data is balanced. You see the age, 50% are here and 50% are there. Means the nature is totally random. Okay. Yeah, yeah, yeah. So what is not balanced? I'm using the word balance and not balanced. That is not correct word. I'm going to use the correct word. I'm going to use the correct word is randomness. Randomness or certainty or uncertainty sometimes called. So these are here certainty is there, uncertainty is there. Why? Whether the person is young, it doesn't matter. It will be more inclined for the investment, yes or no, because there are 50-50% almost chance the person maybe go for an investment, person may not go for the investment if it is young, if he is young. Total random behavior. You can't see the any pattern. Similarly, if the person is old, similar random behavior. You can't say old. If the person is old, more chance go for the investment because the data is saying like that. If the person is either old, either young, total random, it may go for the investment, it may not go, it may not go for the investment, having almost equal probability. It's called equal probability. It may be go right hand side, it may be go for the left hand side. Total random behavior. There is no certainty. With confidence, you can't say the older one will go having a more chance for the investment. So you can't say like that because there is no pattern. There is no certainty. If you are able to talk about, you are able to conclude about person is older size or older size, go for the investment. You can't say like that because data is not allowing you to. But another hand, marriage. If the person is married, you see, if the person is married, yes, then what you are able to conclude, there is a now 80% chance or significant more chance to go for the investment. It is called certainty. It is going to reduce the randomness. Similarly, the another side, no, it's also a certain. Clear is saying 70% they will not purchase if the person is not married. It is again very good situation where you are certain about to say something. You are more confident to make your conclusion because it is more certain. There is no randomness. There is no randomness, or better to say less randomness. It is more certain. It is clear to everybody, or more discussion you want? All the participants, please. It is the interpretation of the entropy. People understand the entropy mathematically. They are more very great to solve the problems, but you ask to them explain it. What is the interpretation of the entropy? So the field. So here, this entropy is 0.5. Entropy is zero point 0.5. So either entropy 0 and 1, both are good. Normally, technically, the positive class point of view talk about entropy 0 is always good. Entropy 0 means all the data will be either this side or either that side. So means if person is young, 100% they are going to purchase. There are no such persons who are young who don't purchase it. It is entropy 0. 100% certain. No randomness. Entropy 0 means. Entropy. So which attribute will give such kind of more discriminative power will be chosen the first. Okay. So that is the whole crux on based on the decision tree or ID3 works on, or any kind of tree works on. Here may be a formula in the cart. There's a different kind of decision tree with maybe the G index, maybe the working criteria. Okay. Good. going ahead. So another example I have to again. Directly jump on the formula how to calculate the entropy of the glass. Now the basic fundamental idea I have discussed. Now time to discuss on uh, uh, how of the class we need to calculate, the entropy of the attribute we need to calculate, and information gain how to calculate. Be with me, the formula is entropy, and there's a two term you try to understand. There's a two term because I'm considering there is a two classes only. Binary class classification I'm talking about. We have a class C1 and class C2. C1, C2 means yes or no, whatever you want. C1 is equal to yes, or C2 is equal to no, whatever the name you want to give. If there is a multi-class classification or there are multiple classes, you may have a further additional terms. So what is FC1? C1 means class yes, suppose. C2 means class no, you suppose. So F means fraction of the class yes. So total number of observations in the data set, how many observations belong to the class yes? It is called fraction of class yes or fraction of class C1 or class 1, 2 or 3, whatever the name you want to give. Try to understand the concept. Log base 2 fraction of the class yes or class C1 minus fraction of the class no or next class. Class no means out of those total number of observations in the data set, how many observations are belongs to the no class or class C2. Similarly, log base 2 of the same value. So this is the example are given for the binary classification. Similarly, interpretation is written over there. The journal for where I is the number and you need to iterate total number of classes you have. C is the total number of classes. If you have a two classes, they will have a two terms. They have three classes, they will have a three terms. And you have to calculate the proportion of each and every class, then log base 2. Then you expand the formula and you just calculate the number. Whatever the number of value you will measure, we will call it as a entropy of that class. For example, suppose this is the one class level attribute is given based on the some parameter, you will play goal for not. Suppose that is a problem is given there. So there were total 14 observations were there in whole data set, and 9 were belongs to the class yes and 5 belong to the class no. Suppose this data set is given to you. Now how to calculate the entropy of that class or that variable? Formula is simple. So entropy 5, 9, 5 means 5 observations are in the one class and remaining observations are in the next class or another class. So what is the ratio? 5 by 14, that is 0.36, 9 by 14, 0.64. This is the ratio, that is fraction I must say. This is fraction of the C1 class, the fraction of the C2 class. You put into the formula minus fraction of this one, fraction of log base 2 of the same value, like that. You put into the formula. Whatever the number you will get it, that is called the entropy of that variable, entropy of that class. Abhishek Tripathi is writing data is it titled towards to left or right? Means your question is that whether the tree will going to be the left hand side and right hand side. The Abhishek ji, you are writing that question. Okay, we will take your question. No issue. I didn't understand your question actually. Abhishek ji. No issue. So this is the way how to calculate the entropy of the particular variable. They may have a big discussion on when come entropy 0, when come entropy 1, like that, what happened. So if the time permit, we will take it. Otherwise, it may be the area where you have to explore by yourself. Now, need to talk about it because it is a bit different. How to calculate the entropy of the attributes. What is the meaning of entropy of attributes? Entropy of attributes means here you need to go for the data set. So this is the class level entropy. We have to calculate only once. Okay, that is clear. We have just seen. These are the attributes. So we have to calculate the entropy of marital status, entropy of the salary, entropy of the gender. And each and every attribute have a different sub labels. Sub labels means gender have only two subcategory, male and female. Salary have a three subcategory, low, medium, and high. Marital status having only two subcategory, married or unmarried, like that. So when you're going to calculate or measure the entropy of the particular attribute, you must consider their subcategories, sub-labels also. So here you need to understand how to accommodate, consider the sub-labels in the formula. That you need to understand it. So you see, for example, we have considered the attribute, suppose the salary, and the salary having a three sub labels, low, medium, and high. Okay. So V means entropy of variable, suppose entropy of variable, how to calculate it. Variable means uh, variable label. It must say the variable label. So we have to calculate the entropy for the low first, the entropy of the medium, entropy of the high. Then we have to combine to calculate the entropy of the whole salary. So it is bit confusing. That's why I'm focusing a lot. A lot of students confused over there. So suppose salary. Salary is the attribute we have to calculate the entropy. You can't calculate it directly. Then we have to do what? We have to calculate the entropy of the first its level. Suppose it have a low, high, medium. Three subcategories are there. We have to calculate the entropy of low, entropy of high, entropy of medium. Then somehow we have to combine it. We have to combine it. Whatever the final term you will, final value you will measure, you will call it entropy of salary. So directly you can't calculate the entropy of the salary. You have to go one by one. Okay. How? Here you need to understand. So suppose entropy of the low I'm going to calculate. So since there are two classes only, you try to remember. You have only two classes, C1 and the C2. Means yes or no. Class variable always come. You can't leave the class variable. So class variable, the C1, C2, there is two classes. Okay. What is the fraction of low under the C1 class? It means like total number of observations under the C1 class. C1 means yes. Total number of observations that belong to the yes class. Out of those, how many belongs to the low? That is called fraction of low under the class C1. Then that value you have to put into the log base 2. Similarly, same proportion of low you have to measure under the next class, that is called C2 class or no class. In case of binary classification, if there is a third class, you can extend that term. So that is the way how to calculate the entropy of the sub label 1 low. Similarly, we have to calculate for the high and for the medium. It is clear to everybody? Some question is there, so result is negative, but it is mentioned Yeah, result is negative. No, no, no. Shashi ji, you have done mistake. So when you calculate that term, it will be the negative. So negative sign is there. It become positive. Similarly, when you calculate this term, it will become negative. So negative sign is positive. Okay, there is no doubt at all. Shashi ji, it is clear. Somehow you missed out the calculation. Okay. So you have to calculate the entropy of each and every level, low, medium, high. I assume that you have calculated, then you have to combine it to calculate the entropy of the salary. So that is a formula to combine it. You see it a bit different. K means number of levels under the particular attributes. In the case of salary, K is equal to 3. So here I'm going to calculate the low entropy of the low. EVI means this the whatever the value you will measure the entropy of the variable low. Okay, then you have to calculate the overall fraction of the low, including the class C1, including the class C2. I means low, and divide by the total number of observations. Then plus for the medium, then plus for the high, because the summation operator is there. So if I expand it, it total number of low in the C1, C2 divided by the total number of observations, the total number of portion ratio under the data set of low. Similarly, entropy of medium, same formula you have apply over here. Entropy of high, the same formula you have to apply over here. Okay. Now I will take one example to demonstrate how it works. Okay. So take this example. Suppose we have a variable outlook. Outlook means salary you can consider. Okay. So salary having a three sub-level like sunny, overcast, and rainy. You can make the analogy like low, medium, and high. There were the class yes and no, like that, like that, like that. Total number of 14 observations are there. So how to calculate the entropy of uh, the outlook? In one line it is written. The proportion of the sunny. Proportion of the sunny is how many observations of the sunny in the data set. Sunny, 3 are in the class yes, 2 are in the class no, there are 5. It is 5 by 14, you see, 5 by 14. And there are 3 observations in the class positive, in the 3 observations class negative. So we have to we have to calculate the entropy of 3 comma 2. So 3 comma 2 means this I'm talking about, this 3 by 5 log base 2 3 by 5, 2 by 5 log base 2 2 by 5 multiply by 5 by 14. 3, because entropy you have to calculate this binary classification, 3 by 5 log base 2 3 by 5, 2 by 5 log base 2 2 by 5. You're going to calculate the entropy of that sunny only, that is 0.971. Then you have to multiply by this formula. Yeah, how many low in the class 1, how many low in the class 2? So how many low? 3 plus 2, 5 are there out of 14. 5 out of 14. It is for the sunny or low, you can say. Similarly, for the next level, overcast or high or medium, whatever you want. Third one is the rainy or the medium or high you want, like for there. You put in all the values, whatever the final value you will get, that is called entropy of that attribute 0.693. You take 1 minute and try to see it is clear to everybody or not. Okay, thank you. So most of the participant, and I hope so all the participants have understood it. Because when you try to understand by yourself through uh, the blogs and the books, it take a lot of time. Here within a 30 minutes we can make it clear all those things. How to use it now? Before going ahead, what's the information gain? We have to calculate the information gain of each and every attribute. The formula is very simple. Whatever the attribute or whatever the entropy of the class, you try to understand. Whatever the entropy of the class, first time we have considered the class level, that was 0.94. Then you have to subtract the entropy of that variable. Whatever the value you will get, you call it the information gain. The more information gain is more favorable. So how the information gain be the can be the higher side? Once you have a lower side entropy, because that is the term that you are going to subtract from the constant. It is going to be constant to every attribute. Class level entropy, that is called 0.94. So if it is 0 or close to the 0, means your information gain of that attribute will be higher side. So that's why information gain always we prefer the higher side. Entropy always preferred to the lower side. The same things you can see the different dimensions. Both are the same thing, like accuracy and the error, like that. So terminological and formula that are being used in the ID3 is clear. Let's have a final look to how to solve, how to create the decision tree using all those concepts. So again, here from the 0, I will take my data set. Then numerically, I will solve one by one how to select the root node, then labels, then labels, then labels, then label. We'll demonstrate how the induction tree grew and what the measure you have to consider during that process. So suppose the data set is given to you, very simple data set. Assume there are 10 observations are there. Gender, salary, marital status are the some input feature. Name I will not consider. And investor is a class level. The data set is then clear to everybody. So what happened? First, we have to calculate the entropy of the class. Total number of 1, 2, 3, 4, n means 4 observations are the negative class, and remaining 6 observations are in the positive class, suppose. So 6 are in the yes, 4 are in the no. Total number of observations are 10. You put into the formula 6, 4, 6 by 10. Okay. Log base 2, 6 by 10 minus 4 by 10. Log base 2, 4 by 10. Solve it. Okay. Why it is minus there? Okay. So entropy of the investor means entropy of the class we have calculated. It is 0.97, suppose. So it is clear to everybody how to calculate the entropy of the class level. Very simple, very simple. Going to the next level, we have to calculate the entropy of each and every attribute. So the order doesn't matter. Means you may start with the salary, gender, and marital status randomly. The order doesn't matter because anyhow at the end, all the three variables or attributes, the entropy you have to calculate it. Then you have to compare it. So then that means order doesn't matter. You start with randomly with any of the attribute. Suppose we have started with the salary. Okay. Number of value in the salary means number of sub labels in the salary. Value means sub labels like low, medium, and high. So we have to calculate the entropy of the salary with respect to the class level attribute investor. So that is the formula. Here, for a simplicity, I have made over here. There are such three observations comes under the law. There are three observations come under the law. 1, 2, and 3. I think everybody get it clear. 1, 2, and 3. Make numerical very simple way so that it doesn't create any confusion. And out of three attributes, one is in class yes and two are in the class no. Okay, you can reconfirm it. Low class no. This low is also class no. The last low in the class yes. Okay, so going ahead, yeah, put into the formula. Formula is talk about fraction of the low. Fraction of the low is 1 by 3. Okay, 1 is the class C1, 2 by 3, log base 2, 2 by 3. Calculate the value. It will be the entropy of the low. It is 0.92. Similarly, we have to calculate the entropy of the medium. Having such 5 observations under the medium, you can go and reconfirm it. And similarly, you have to calculate 3 by 5 log base 2, 2 by 5 log base 2. Okay, entropy is 0.97. Third is high. Luckily, high having 2 observations, all 2 are in the class here. It's the ideal case. The entropy will be 0. There is no randomness. If your salary is high, what is the meaning of that? In the machine learning, interpretation is more important. If your salary is high, you will invest. Okay, so you mathematically you can reconfirm it. 2 by 2. Favorable condition. Entropy 0 means it is a pure data set. So somebody have written that terminology in the chat box earlier, the pure data set. So what is the meaning of pure data set? I will cover. First put all those value into the formula. Total entropy of the attribute means what? That formula we have already explained. So the fraction of the low 3 out of 10, fraction of the medium 5 out of 10, fraction of the high 2 out of 10. Entropy of the high is 0, entropy of the medium is 97.97, entropy of low is 0.92. You put it into the formula and calculate it, you will get the entropy of the attribute salary. One stage is remaining, the information gain of the salary, that you know the entropy of the class level, that was 0.97. You need to subtract the entropy of that variable salary, that is 0.76. Whatever the value you will get, that is called the information gain of the salary. Okay, it is clear to everybody? Thank you, thank you. Okay, so the summary is written over here. So because for the next attribute, I'm not going to explain each and every mathematically. The summary is written over there. Try to understand. So similarly, here we have considered the next attribute, gender, having sub-level male and female. Male out there are 6 attributes. 4 are in yes, 2 are in no. And the entropy of the male is 0.92. The whole salary is 0.95. Entropy of the information gain of the variable gender will be 0.016. Similarly, the next attribute marital status we have to consider. Put it all into the formula. You will get the entropy is 0.92 of the marital status. Information gain of the marital status is 0.465. How? We have to subtract this value from the entropy of the class. Good morning, good morning. Total summary is written over here. Now in the first iteration is about to over. In the first iteration, we have considered all the possible attributes. In the given data set, we had only 3 possible attributes: the salary, gender, and marital status. I have demonstrated how to use those formula to calculate the information gain. And we have finished that calculation. The information gain of the salary, gender, and marital status we have measured, and the summary is before you. Now easily you can decide which node you should select for as a first splitting node. So the node which gives you the highest information gain will become the first split node. In theory, I have explained all those things. It is clear to everybody. In the theory, I have explained all those things. The attribute or the variable that gives you the highest information gain will become the split node. Okay, so what is the meaning of that? The salary will become the node. Under the salary, there are 3 sub branches because the low, medium, and high. We have started creating the decision tree. The first level of the decision tree is ready. It is okay? Yeah. So see, you are wrong, totally wrong. Please hold it, hold it. We have selected the salary. After the salary, it is the beauty of the machine, beauty of the decision tree. You need to understand. Many people do this mistake. They concluded first you have to select the salary, then marital status because the sequence is like that. Then gender. No, not at all. Not at all. It is a blunder mistake. Be with me next 10 minutes. I will explain. Yeah, it is not conclusion. More difficult things are there. Here, yes is written over there in high. Why? Because high was the pure data set. So that you need to understand when we have calculated the high. You see the high. If any of the attribute against which all the observations either in the class yes or either in the class no, or any of the observations where the entropy will be 0 will be considered as a pure node. So if you have a pure nodes, you directly make the decisions. You don't need to further split that node because what you are claiming, any of the person, I don't worry about what is the marital status, what is the gender. I don't need to see it because all those person in the data set, it says that if the income is high, salary is high, they will invest. So why I don't why I need to check about their marital status? Whether they are married or not, it doesn't make any difference. Whether the person is male and female, it doesn't make any difference because all those observations Total, all the observation in the data set, income is high, they invest. So there is no confusion. This kind of data set or group, if appear during the tree induction, we call it pure data set. We don't need to further divide or split that node. Directly we can give the decision yes. Yes means the decision you have made. Investor, yes, it is saying yes. It's a bit difficult to understand, but try to understand what I'm saying. In the case of low and medium, you can't make such conclusion. Okay, so what you need to further split the node low, and you need to make the split the node medium. So here the most of the person do the mistake. Have point, then you have split low and medium. I am not touching because it is the leaf. I become leaf. Leaf means we don't need to further split. In the low, we have two options. Either we select the marital status or gender. Here again for the split, we have to select the particular node. I can select the marital status or gender. So please make it clear, all the participants, please. Here there is no such rules. This node may select the marital status for the next split, and this node may select the gender for the next split. Never develop misunderstanding. The one level of the decision tree must have the same attribute. No, not at all. This is the next level. Under the low, the splitting node may be based on the marital status. Under the medium, the split node may be based on the gender. That's why when Sasiji has written salary, marital status, and gender, I raised the point. It is not like that. So there is no such rule. Okay. The same. Shashi, wait. So question is that how you will decide it? Whether the next node under the law will be marital status of the gender. Under the medium, what you are going to select, the gender and marital status. The same process we have to repeat. That's why I call it the recursive process. The same process we have to repeat it. Let me demonstrate it for you. Question is, which is the next node? Yeah. So we are focusing one by one to examine everything. Starting with the low. I'm going to focus over here the low. I will decide the next node. Then I will demonstrate the same process we have to apply with the medium and need to decide the next node. Suppose this is the sub data set against the low only. You have to cut down, or you have to find out the subset of the data set where you want to going to focus on. So the salary low is my objective. So this is the complete data set. Now we have to work with that one. So what are the options you have now? We have options gender and the marital status. Agree that we have a confusion under the law, which going to be the next node, gender or marital status. It is clear to everybody. Under the law, next question is whether is marital status or the gender. That is the question. We have only two options. Agree or not, everybody? Yeah. So we have to calculate the information gain of the gender. We have to calculate the information gain of the marital status, and need to select which attribute giving the more information gain. So let's calculate over here. First, we have to calculate the class entropy. Forget that class entropy. One process is over. You have to reinitiate all the process. This is the complete data set. That's the class label. So first, we have to recalculate the entropy of the class. So here, yeah, I have written somewhere. Okay, I will discuss later. So entropy of the class we have to calculate, because without the entropy of the class you cannot calculate the information gain of the attribute. So start with the simple one. I have to select the gender, and the gender having two observations. Hmm, yeah, value. Yeah, male. Under male, there are two observations. One are in yes, one are in no. Under the female, only one observations, that is no only. That is no only. So you put into the formula that we have discussed to calculate the entropy of the attribute, and the entropy of the attribute is 0.666. Okay, 0.666. Here, the information gain, we have to subtract it from the class entropy that you have to create from here. You have to we have to recalculate the entropy of the class label. Okay, so that older entropy of the class label, you should not consider it. Okay, I forget to mention over here. Please keep it in mind. Similarly, the entropy of the next attribute, marital status, we have to consider. Two are married, two are unmarried, one is married. So two are married, two are unmarried. They don't invest, and who is married, they invest. So there is an entropy 0, and information gain is total information gain of that marital status is 0.923. So you need to summarize it. So this is the information gain under the law. I'm talking about under the law. The information gain of both the possible candidates are here. Okay, so here which attribute you will select? It is damn clear. Marital status or gender? I think marital status. Everybody agree. So you see the marital status. Marital status, yes or no? So again, it becomes the leaf. Why? Because this is the pure data set. Marital status. You see the marital status. You see, if they are married, all such observations will invest. There is no confusion. If they are unmarried, all will not spend. All will not spend money for investment. So it's a pure data set. So you are lucky to have. So the leaves are there. You don't need to further go into that direction. Agreed? Now focus on the medium. In the medium, we have again the same choice, either marital status or the gender. So this is the data set I have created under the medium. Under the medium, this is the sub data set. We have to consider from the whole data set whatever you have given. You have to select out, filter out all observations that salary is medium. So again, you have to calculate the entropy of the class. You have to calculate, and then calculate the information gain of the gender and marital status one by one. Let's go it. Male. There are three males. Two are the investor. One is not investor. Three males. One, two, three. This is not investor. This is investor. This is investor. Similarly, female. One is yes. One is no. Put into the formula. Uh, Whatever the information gain, you have to calculate it over here. Similarly, for the marital status, you have to apply. Summary is here. There is a tie. Both the attribute having the same marital or same information gain. So don't worry about that. Randomly, the system will select anyone. Suppose you have selected gender for the next split. This is the things. In the medium, gender is the next split. Again, the gender, what happened? You have to go one more level. Okay. So next, in the gender, we have to select one by one. Salary medium, gender male, gender male. This is the new tables. Calculate the class entropy, calculate the entropy for the male. This is the for male, this is the for female you have created. and based on the majority. So here there is a confusion. Look, the female who are the married, okay, then they are not an investor. The female who are unmarried, they are the investor. So that is a pure data set. Luckily, males who are the unmarried, they don't invest. Who are the male who are married, invest. So there is a, luckily both are the pure attributes or pure data set created. So that's why conclusion we have made. A male married, if they married, they invest. If they don't married, they don't spend. Similarly, for female, married never spend for the investment, and marital status is unmarried, they go for the investment. So this is the complete tree we have demonstrated. So the things are never simple many time. Many time it is not easy to find the pure data set. So we have to keep on going until you have a attributes for the splitting. If you have don't attributes, if you don't have any more attributes, means suppose you have taken all the attributes, you have taken salary, you have taken gender, you have taken marital status, then you have to stop it. Wherever the things are there, you have to stop it. You don't have more attributes, you can't go for the next split, you cannot grow the tree. Okay. So last but not this in last the least but not the not but very important thing I was going to cover stopping to see process. Sometimes it's not to grow or make a huge or large tree. So tomorrow class I will cover why. So you can define at the starting the max number of leaf node. Already that is criteria you have made. You are growing the tree, you are growing the tree, you are growing the tree, and you have found whatever the maximum possible number you have set at the beginning, suppose 20, 30, 50, total number of leaf already there, you have inducted into the your decision tree, you stop growing. Whatever the condition, don't worry about, you stop growing. So that is one of the stopping criteria. Another stopping criteria may be the depth of the tree. It is a parameter, it's a hyperparameter. When you call the function in the R and Python, you have to set all those things. The stopping criteria means uh, your depend on the attribute, on the size of data set, like that. Once trees start growing, once it reach to the threshold with respect to the depth value, it's reached, it stop growing. Similarly, minimum number of observation in the node. What is the meaning of that? Minimum number of observations in the node. Suppose this is the tree, we are growing. So we have to see every time number of observations in the node, any node. I did the node minimum having 10 observations. So suppose this observations having 9, this node having 9 observations. So we should not split it. We should not split it. We stop over here. So you apply that rule to each and every node. And if node having more than 10 observations, you can go for the further split. Otherwise, you have to stop it. So it is the all the ways I am discussing only to restrict to growing the tree, because having a large tree, huge tree is not good. So these are all those things that restrict, that stop you attribute in the next level to candidate to become the split node. Automatically you have to stop it. No examples in the data set. Sometime You have an attribute, still there are attributes, but all the observations are finished. All the observations are settled down in the pure nodes. It may happen, attributes are there, but all the data set are splitted, or based on the characteristics of the attributes, there is no observations left. They become most of the node at the lower side become the pure node. Should split it. There are many more criteria. One the last criteria I'm going to discuss. Suppose this is the tree, any node, not tree, any node. I'm going to split it. Suppose information gain of your node was 20.56, or once you split, the information gain is 2.1 or 2.0, like that. So if you are not increasing the information gain, means the information gain is reducing. You see 2.56 it was there, now it is reducing. The information gains you are reducing means impurity. Impurity you are increasing. Uncertainty you are increasing. My objective is to growing the tree to increase, to reduce the impurity. But it is observing the behavior. We should split that node. We should not split that. If the node is split cause more impurity, we should not split it like that. So that is all about the ID3, the algorithm under the decision tree. That was the plan to cover in the session 1 in this FDP day 2. So now the question answer session is open. If any of the questions you have, please write on the chat box. So CG have written something that I can't understand, but you are writing in the you are clear, happy. So if the things are clear to you, it is my only objective of the FDP, objective of the institute, objective of the AICTE. So I hope with the limited time, whatever the best possible way that I could do, I tried to make you understand about the decision tree, especially ID3. Any of the question I have, I hope so. There is no question. And once you start learning by yourself, there are a lot of resources, lot of videos, and things are there online. You can solve your questions, your doubt. A small announcement about the next lecture. So we have a next 2 lecture from like 11:30 and 3 p.m. It is going on the it is a deep is we RNN, all are in the deep learning. It is CNN. I think hands-on will be there. I have invited Dr. Oja. He's my best friend. He's going to take the next 2 sessions, and next 2 sessions is going to be very great because he's so famous in that area of deep learning, CNN, RNN, and he has taken a lot of courses outside India. Next session is so important, so important. A good teacher has already gone through the many resources, learning from the teacher, leaves the learning about. Agree. So CG, agree that. So similarly, you are going to enjoy a lot. So that's why forcefully I'm requesting to really, if you have a time, please be serious and attend next 2 lecture. Tomorrow morning again, every morning I will I usually take the lecture every morning. So tomorrow morning I will going to take the cart. Cart is a decision tree algorithm. Okay. I will also discuss about the pruning. You might have listened that word, pruning. So tomorrow morning again my lecture that will be on the decision tree continue. Next two lecture about the uh, uh, deep learning and the OJAS will take over there. So thank you. And over here, will be having a 30-minute break. Will be 1:30. We always go with the time. You will observe in the next 5 days. The time is immediately what you share with you. You will start, will end on the time. So thank you. We will meet again after 30 minutes. Meanwhile, I will try to share the attendance. And maybe next year, maybe next to next session, I will going to share the attendance. Thank you. Thank you. Let's meet before 11:30. Thank you. Thank you. Thank you. I request you don't leave the classroom. Be over there. Be continuous login. You may continue from the 11:30. So don't leave the classroom. Thank you.
So will you share the attendance now?
I may share in the next session, maybe next to next. Randomly, I will do. I will not announce when I'm going to share the attendance.
No,
It will come randomly.
like yesterday, you can put it in the chat, sir. Like because when we are seeing your screen, we will miss the chat session. So that's why I'm asking, requesting actually.
So I will, maybe it may be in the next session or maybe next to next session.
Okay, okay, sir. Thank you.